So my name is Jyrki Saarinen. I come from the Joensuu, from the University of Eastern Finland, and in my responsibilities to be a vice director of the program. In our program, we decided to split the responsibilities for the science and impact side, and my responsibility is the impact side. So let's start. What is the most important process on Earth, and what do we need for that? And I guess it's a photosynthesis. So without that, we wouldn't have any forest. Like my colleague Jyrki Kangas in the very first Forest and Photonics event said that without light, there would be no forest, no trees. And for that, of course, you know we need light, we need water and carbon dioxide. And what is photonics? Photonics is the science and technology of light. And the old words that has been used are for optics and optoelectronics. They are not that popular anymore, so the community is trying to now push the word photonics. So it's basically a branch of physics which studies the generation of light, the transmission, modulation of light, and then also the detection of light. And usually we consider not that what belongs to the photonics is not only the visible light, but also the infrared and ultraviolet light. And I could spend a whole day, a week on explaining you the importance of photonics. But there are many areas where actually you are involved with the photonics. So whether it's about the internet today, whether it's about the manufacturing, mobile phones, televisions, lighting, and cameras, and whatever, just the recognition systems and so on. Anyway, there are lots and lots of applications where it's crucial. And it has been said that basically when the 19th century was basically about the mechanics, the last century was about electronics. We got a lot of nice innovations based on electrons. So this century would be the century for photons. So in our flagship, we believe that we need also very strong fundamental research. So it's all about from research to the commercialization, like you have also heard about the importance for that point. We have 4 partners in this flagship. We have Tampere University, we have University of Eastern Finland, Aalto University and VTT. And basically, let's say, we are kind of, let's say, we have main programs on the materials, because that's important in photonics. It's about the structures. So you already heard about nanostructures, nanophotonics for the biomaterials. So that's important also for us. Then from components and materials, or structures and materials, we can build components. And from components, we can make systems. And the first kind of, let's say, main topics are on 3D lidars that I guess you are going to hear a lot during these 2 days. Then also various kind of sensors and also photovoltaics for solar cells. So, but these are only the first key focuses for the applied research side. There will be a lot of new things that we want to identify during this eight-year journey. About the applications, if we look about which are kind of relevant for these 2 days, I would say, like I mentioned, lidars are very important application. I don't explain because I guess some of the other lecturers will tell you more about, but it's a light detection and ranging technology. Then different kind of cameras and imaging. I guess you are going to hear also nice topics about these things, how you can use visible or infrared cameras to learn about the forest fires and so on. And like you have seen, what is going on at the moment is that a huge development and fast development of cameras. So your mobile phones don't have anymore one camera. It has actually many cameras. So the whole imaging technology is kind of, let's say, changing. Then that this kind of spectral imaging or hyperspectral imaging is very important. You can get much more information out from the materials, insects, from human living things, from plants and so on, just by taking photographs with these spectral imaging cameras. And then I guess you are going to hear a lot about the laser measurement, how we are using the lasers for measuring distances, thicknesses, whatever. And of course, when we are talking about the different kind of materials, we heard about the biomaterial development. You couldn't do that without another photonics application, that's microscopy. This is also a very nice example about what kind of role photonics can play when you are making volume production of any of the biomaterials. So this is from Markku Mäntylä from Valmet Automation. Unfortunately, this is only in Finnish. But anyway, you can see that using different kind of wavelengths, you actually measure already now in the paper making machine. You measure a lot of different kind of things with photonics sensors. So the photonics is becoming more and more important for collecting this information, whether it's a human being measuring your pulse, heart rate, or whether it's any of these kind of, let's say, materials. Then, of course, very important thing, if you think about the environment, is already what we learned a long time ago. If you can't measure it, you can't improve it. And that's why, for example, when we are talking about environmental measurement, pretty many of them are based on photonics. So whether it's a LiDARs, whether it's about the cameras, imaging, different kind of optical sensors, spectroscopy is a huge area. I could spend another week talking about various kind of spectroscopic applications and so on. So a lot of information that you gather is you need optics for that or photonics for that. And then if we talk about kind of, let's say, saving the environment, then of course the solar cells may be a good candidate for making green energy. And maybe someday the laser fusion works and you can create unlimited amount of energy. Who knows? Then on the other side of saving energy, photonics is also very important. The bad thing for the photonics is, of course, so-called light pollution. If you look about the Earth from this very long distance, you see a lot of light coming from the Western countries, and that's kind of, let's say, light that you don't want to go out. So it's a kind of unnecessary light. So that's why the LEDs are playing very important role for saving energy. And when we go to the smart lighting, where we combine different kind of moving sensors and so on, we can actually put light to the place where it's needed. And this will be another major impact for the saving the energy. And then finally, just about what is our local role here for the PREIN flagship is that we are doing that in the Institute of Photonics, which actually combines the photonics research at UEF. It's a multidisciplinary topic already even inside our university, because there is a chemistry, physics, school of computing, biology and applied science, applied physics involved. And then of course we have a lot of collaboration. So we are working already with the Karelia University of Applied Sciences, Riveria, then Photonics Finland, which we heard about already from Juha. And actually I'm very glad to say that Juha is also now playing as an impact manager for the PREIN flagship. So he's also playing an important role for the impact side. So Photonics Finland is important part because we are organizing a lot of events through that, like this event. Then Business Joensuu, European and Optical Society, also based here in Joensuu, the Joensuu City, and also the Regional Council. And we also really like about the topic that Juha brought all the 4 flagships together, because we also believe that we need multidisciplinary discussion, ideas and so on, so that we can create a nice future together. Thanks.